Well, good morning everyone. Today we will start with question number 3 of exercise 3.2. So the question says the numbers 13 and 31 are prime numbers. Both these numbers have same digits 1 and 3. Find such pairs of prime numbers up to 100. Means up to 100 you have to identify such kind of prime numbers which are having the same digit. Now coming to the solution, for your comfort I have written the numbers from 1 to 100. Here it should be 100. Now, if you remember the divisibility criteria of the various numbers that we have already read in our previous classes, and that is in our 5th standard. So, all those numbers which are having either even digit or 0 at their unit place, they will be divisible by 2. It means the numbers, those kind of numbers will not be your prime numbers. Now, suppose 1 can be written as 01, 2 can be written as 02, 4 can be written as 04, like this, up to 9 we can write. When we are reversing the digits, means 01 will be written as 10, 02 will be written as your 20, means at the unit place they will be having 0. It means this entire column is divisible by 2. Therefore here you don't have any prime number when you have reversed the digits. Same is the case with this row is also having 0 at the unit place. Therefore this row also don't have any prime number because all the numbers are divisible by 2. Or you can say this row and this row are having more than 2 factors. Now you have to eliminate or eradicate all the even numbers because all those even numbers are not your prime numbers and you have to look for the prime numbers. Therefore this entire row will get eliminated, this entire row will get eliminated, this entire row will move out of race, and this will also move out of race. At the same time, again all those numbers which are having even number at their tens place, when the digits will be reversed, means if I consider this row, then 21 will be written as your 12, 22 will be written as 22, 23 will be written as 32, 24 will be written as 42. So on reversing the digits you are finding even the odd number is giving you the even number. Therefore the pair is not possible. So all those numbers which are having the even digits at their tens place will also move out of race. Therefore this entire column is moving out of race, this column is moving out of race, this column is moving out of race, and this is also moving out of race. At the same time, all those digits which are having 5 at their unit place are divisible by 5. It means they are having more than 2 factors, one number itself plus 5. Therefore this column is also moving out of race. Again this 33, on reversing the digits will give you 33, so you are not getting any other number. Therefore these kind of numbers are also out of race. 55, your 66, 77, 88 is already out of race, and your 99. Now you have to identify from the remaining numbers that which is the prime number following the criteria of the question. Therefore coming to this column, 11, 12, 13, they are out of race already. The 13 is already given to you, 13 and 31. The next 14 out of race, 15 out of race, 16 out of race, 17 and your 71. Both are your prime numbers. So one pair is your 17 and 71. I am writing here 17, 71. 18 out of race, 19 and 91. 19 is a prime number, but 91 is not a prime number because it is divisible by 7. Therefore it is also out of race. Now this column again out of race. 31, which has been already considered with 13. 32 not considered, this out of race, this is out of race. 37 and your 73. 37 and 73 both are your prime numbers. Therefore this is also the case. 39 itself is not a prime number. Then this column is out of race. Then 51 will give you 15, which is not a prime number. 53 will give you 35, not a prime number. 65 is not a prime number. 75 not a prime number. 59 will also give you 95, which is not a prime number. Then coming to this 70s column, because 60 is already out of race. In this 71 has been covered, 73 has been covered, 74 out of race, 75 out of race, this is out of race. Now 78 is not a even number, so is not a prime number because it is divisible by your 3, as well as it is divisible by 2 as well. 79 and 97 both are your prime numbers, so the third one is 79 and 97. 91 not possible, 92 not possible, 39 not possible, 94 not possible, 95 already out of race, 96 out of race, 97 we have already covered, and the rest 3 are already out of race. So in this way you have to identify the numbers. Yes, the question is lengthy, that's the reason I skipped in the first video. Now coming to the question number 6, express the following as the sum of two odd primes. Means whatever the numbers are given to you, you have to write down in the addition form as the sum of two odd primes. So the solution is 44. It has been broken as 77 plus 37. Both are prime numbers. It can also be written as 13 plus 31. It can also be written as 3 plus 41. So there can be multiple answers. What you have to do is first subtract any of the prime number from the given number, and then what all the result you are getting, check that is that prime number. If it is, then your condition is satisfied and you can write 44 in terms of those two numbers. Similarly 18 I have done for you. 18 can be written as 5 plus 13. 18 can also be written as 7 plus 11. Moving ahead, question number 9 is write 7 consecutive composite numbers less than 100 so that there is no prime numbers between them. Means you have to write down the 7 consecutive means continuously you have to write down 7 composite numbers up to 100, मतलब 100 से कम ही हो वो, so that there should be no prime number in between them. This question I have not done. I have simply write down the answer. You have to do it by yourself. Answer has been written for your sake of comfort. The answer is 90, 91, 92, 93, 94, 95 and 96. Write down the numbers like this and identify. Now question number 10 is express each of the following numbers as the sum of three odd primes. Means in the previous question we were expressing a number in the sum of two odd primes. The same is the case here, but here you have to express the number in the sum of three odd primes. Here I have done one part for you, that is 31. 31 can be expressed as 3 plus 5 plus 23. Also it can be expressed as 5 plus 7 plus 19. Question number 11 is write 5 pairs of prime numbers less than 20 whose sum is divisible by 5. Means you have to identify those 5 pairs less than 20 whose sum is divisible by 5. Means when you are adding the two digits or the two numbers of the pair, their sum should be divisible by 5. Here is the solution. Number up to 20 which are divisible by 5, means up to 20 those numbers which are divisible by 5 are your 5, 10, 15, 20. So your aim should be that when you are finding out the prime numbers, then their sum should come out either 5, 10, 15 or 20. Now therefore the required pairs of prime numbers are starting with 2. 2 is a prime number, therefore 2 plus 3 will give you 5, 2 plus 13 will give you 15, right? So with the these two pairs are possible. Now coming to the 3, with 3 you cannot make 5 because already you have made the 5 with 2. So 3 plus 7 is your 10. Then for making 15 you need to add 12, and 12 is not a prime number. Therefore your next aim is to make 20 with 3. Therefore you need to add 17 to 3 to get 20. So your fourth pair is this. Now with the 5 you cannot make the pairs. Next prime number is your 7. 7 you cannot make 5, you cannot make 10 because you need to add 3 to the 7 which has been already formed. So the next one is 15. 15 number you cannot add because to get result 15 you need to add 8 to the 7, and 8 is not a prime number. Therefore next target is 20. So when you are adding 13 to 7 you are getting 20. Therefore the required pairs are 2, 3, 2, 13, 3, 7, 3, 17 and 7, 13. This is not of your syllabus. So that's all for today. The pic of the exercise will be sent to you separately for your practice purpose. Moreover, go through the rules of divisibility, because in the next exercise we are going to use that, and we have already covered the rules of divisibility in our previous class.